Hi there. We're going to tackle a problem here which involves using many of the rules that we learned throughout the unit of mensuration as well as the unit of trigonometry. So we're going to use basically a Pythagorean theorem. We're going to use the formula of finding the area of a triangle, which is half times base times the height, as well as we're going to use the cosine rule to find an unknown angle. We're going to use the formula of finding the area of a sector and the formula of finding the area of a triangle, once again, which is half times side 1 times side 2 times sine the angle between the two sides. And then we're going to use the formula of the volume, which is used in 3D objects only. And the formula of the volume states that, or is equal to, area of the base times the height or the vertical distance between the two identical opposite bases. This is a summary of all the rules that we're going to use in this problem. Let's read the problem together and let's figure out how we're going to apply the rules that I mentioned at first. The diagram shows the cross-section of cylindrical pipe. Cylindrical pipe is a 3D object. The cross-section, which is shown in the drawing here, is actually a two-dimensional drawing with water lying in the bottom. So the shaded area is actually showing the water that is lying in the bottom of this pipe. If the maximum depth of the water is 2 centimeters, the radius of this pipe is 7 centimeters, find the area shaded. Let's at first place the numbers that are given to us in the question on the sectional drawing as following. If this is the center of my pipe, the distance, this is the distance from the center to any point on the circumference is called the radius. This radius is actually equal to 7 centimeters. The distance from here down there, as shown, as the arrow is showing, is actually the depth of the water, which is 2 centimeters. So we are here, we are reflecting the given numbers in the question on the sectional drawing. So the remaining distance, which is from here to here, is actually 7 minus 2, which is 5 centimeters. Okay. Again, the distance from the center to any point on the circumference is called the radius. So this is r, which is equal to 7 centimeters. And once again, the distance from the center to any point on the circumference is called the radius. So this is r, which is equal to 7 centimeters. As you can see here, why did I draw the last two lines? Because we are always trying to find a sector and a triangle. If you have a look here, we actually have, when we use the depth of the water, okay, the points of the depth of the water, we created a sector as well as a triangle. Perfect. So let's name the points. If this is point A, this is point B, so this is point C, the center of the circle, and this intersection point here, this intersection point here of the vertical line that we brought from the apex down to the depth of water, to the straight line of the depth of water, which actually is, if we consider AB is the base, So AE is equal to EB because this triangle ABC is an isosceles where two sides are equal and this is the base. So when we bring an apex, a line from the apex down to the base, it's gonna bisect the base into two equal parts. And this line from the apex down to the base is perpendicular on it. So there are 90 degrees angle created with the base. So if this is AE is X, then EB is X as well. Because as I explained, this line from C down or the apex down to the base, which is AB, is gonna bisect the base AB into two equal parts, X and X. Accordingly, if we go, so we have here two right angle triangle, AEC and CEB, two right angle triangle. If I take the first right angle triangle on the left, which is AEC. So we know that the hypotenuse is actually AC, which is equal to R because it's the radius. It's the hypotenuse in triangle AEC and it is the radius of the circle. So it's equal to 7 centimeter. And then we have side AE, which is called X. And then we have the height here. We called it H, which is 5. And we explained how we found it. We subtracted the length of the radius from the depth of the water to find this distance here. So now we are going to apply Pythagorean Theorem to find the unknown side, which we named it X. So the Pythagorean Theorem states that hypotenuse to the power of 2 is equal to side AE to the power of 2 plus the perpendicular side on it, which is CE all to the power of 2. Let's substitute. The hypotenuse is 7. So it's 7 squared is equal to side AE is my unknown and we named it as X. So it's X squared plus side CE, which is equal to 5. So plus 5 squared. So we wrote the Pythagorean Theorem rule. We substituted in the Pythagorean Theorem rule. Now we're going to apply opposite operations. Don't use the calculator yet. So we're going to subtract 5 to the power of 2 from each side because we are making X the subject. So X squared is equal to 7 squared minus 5 squared. Don't use the calculator yet. We're finding the 1x. So we're going to square root each side. So x is equal to square root of 7 squared minus 5 squared. Now this is ready to be inserted in this calculator. And if you do so, x is going to come down to 2 square root of 6 centimeter because all the dimensions are given to us in centimeters. So we found the 1x. So in triangle ABC, in the big triangle, in the isosceles triangle ABC, the base is x, which is AB. The base AB is actually equal to x plus x or 2 times x. So it's going to be 4 square root of 6 centimeter. And the height, which is the vertical, not the R, not CA, not CB, it's the vertical height, the distance from the apex down to the base or perpendicular on the base AB. So the height or the vertical height is actually equal to 5 centimeter. Accordingly, sorry, I just want to correct one thing. We don't need this one, so I'm going, and here I want to say in the I hope that I'm writing it correctly. In the isosceles triangle ABC, and let's get back to the presentation. So in the isosceles triangle ABC, the base, which is AB, is equal to x plus x, or we can write it as 2 times x, so it's going to come down to 4 square root of 6 centimeter, and then side CE, which is the perpendicular height on the base, and it is h, which is equal to 5 centimeter. Now let's use the formula of finding the area of triangle ACB. And the area of this triangle is half times base times the height. Let's substitute. So the base is, so we wrote the general formula of finding the area of a triangle. So the base is equal to 4 square root of 6. And then, so we are going to substitute the base with 4 square root of 6 times the vertical height, which is 5. This is ready to be inserted in the calculator, and if you do so, the area of triangle ABC is equal to 10 square root of 6 centimeter squared. Remember that the measurement unit of the area is centimeter squared, millimeter squared, and so on. Now, so we found the area of the triangle. We need the area of the sector. We need the area of the sector in order to find the shaded area. So, in the isosceles triangle ABC, let's use the cosine rule to find the unknown angle theta. We named it theta to find the unknown angle, which is ACB. We named it as theta. The other two angles are going to be named beta, because in an isosceles, if this is theta and this is the base, the angles of the base are actually equal to each other. So these are the two equal sides, and this is the base. The angles of the base are always equal. If this is theta, then this is beta, and this is beta. We're going to use the cosine rule to find the unknown angle theta, or we named it ACB. Okay, so what is the opposite side to angle theta? It's AB. So we're going to say AB squared is equal to, what are the other two sides? AC or CA and CB or BC. So BC squared plus CA squared minus, in brackets, 2 times BC times CA times cosine the angle between the two sides, which is theta. Let's substitute. So before we substitute, if AB is actually equal to 4 square root of 6, and we explained in the previous steps how we found x, and accordingly we added them to each other to find AB. BC is actually equal to r, which is 7. CA is actually the radius of the circle and is equal to 7 as well. Now let's substitute in this formula. So AB is actually equal to 4 square root of 6 to the power of 2 is equal to 7 squared plus 7 squared minus, in brackets, 2 times 7 times 7 times cosine the unknown angle theta. Now, so we wrote the general formula of the cosine rule. We substituted in the cosine rule. Now, all what we need to do is to simplify. So, 4 square root of 6 is going to come down to 96. And 7 squared plus 7 squared is 98 minus, then 2 times 7 is 98 cosine of theta. Now we're going to apply opposite operation. So we're solving for theta. We're going to get rid first of the 98. So we're going to subtract 98 from each side of the equation. 96 minus 98 is going to be minus 2 is equal to, and 98 is going to be cancelled with this 98. So it's going to be minus 2 is equal to minus 98 times cosine of theta. Let's apply opposite operations as well. So we're going to divide each side of the equation by negative 98. The negative 98 is going to be cancelled with the negative 98 on the right. So it's going to be cosine of theta is equal to negative 2 over negative 98. But again, we are solving for theta. We are finding the unknown angle. So we're going to apply cosine inverse now. So theta is equal to cosine inverse of negative 2 over negative 98. If you insert this in the calculator, the angle theta is equal to 88.8 degrees. So now that we found the unknown angle, so we know theta, we know AB, we know BC, and we know CA. So we are solving for this because we want to find the shaded area. So area of the sector minus area of the triangle. We found the triangle. Now we're going to find the sector. Area of the sector, we write the general formula of finding the area of a sector, which is angle of the sector over 360 times pi r squared. Angle of the sector, we found it in the previous step, which is 88.8 over 360 times pi r squared, and r is already given to us. Let's substitute in this formula. So it's going to be 88.8 over 360 times pi times 7 squared. Insert this in the calculator and the area of the sector will be 37.98. If you want to round it, we don't need to round it because we're going to use this figure once again. But let's say that you want to put it correct to 3 significant figures. You're going to stop at 9. 9 is going to be upgraded to 10 because there is an 8 to the right of the 9. So the final answer will be 38.0 centimeter squared. Now, so the shaded area, so we found the area of the sector in the previous step, and now we need to find the area of triangle ABC. So it's going to be half times 7 times 7 times sine of the angle between the two sides, which is 88.8. If you substitute this in the formula, you're going to find the area of the triangle as 24.5 centimeter squared. Now, you must subtract the area of the sector, the area of the triangle from the area of the sector. So the shaded area will come down to 13.5 centimeter squared. So this is how we calculated the first part in the question. The second part of the question is where we're going to use the formula of finding the volume in a 3D object. Let's imagine that this is the pipe as a 3D object. This is a cross section here that is shown. Okay, so this is my cross section. I found the area of this cross section. So the area of this pink part here in the pipe, we found it as 13.5, and we explained all the steps of how we found the area of this part. Now, they're telling us what is the volume of water in a length of 30 centi. So the length is from here to here, which is going to be 30 centimeter. Remember at the very beginning of this video, I explained that the general formula of finding the volume is area of the base. The base is this one. This is my base, okay? Because how do I know the cross section? If you go to the end of the 30 centimeter, you can have a typical shape to this one. So this area, so this is my base. We found the area of the base times the height, which means the distance between the two identical opposite bases. Because the water, it will go all the way throughout the 30 centimeter. So in the end of the 30 centimeter, you're going to have a typical face to this one, or a typical base, face or base to this one. So let's substitute now. The area of the base is 13.5 times the height, the distance between the two identical opposite faces or bases is 30. If you insert this in the calculator, you're gonna end up with 405. This is correct, 405 centimeter cubic. Because 4, start from the left, 4 is the first figure, 0 is the second, 4 is the third figure, you stop at the third figure, look at the right, 6 is gonna bring this 4 up to 5, so the final answer is 405 centimeter cubic, and this is the volume correct to 3 significant figures. Have you noticed that the measurement unit of the volume is not centimeter, not centimeter squared, it's centimeter cubic, centimeter to the power of 3. Please watch this video again so that you understand how we applied the different formulas of calculating, of using Pythagorean Theorem, of calculating the area of a triangle using the formula half times base times height. How did we find the missing angle using the cosine rule? How did we find the area of a triangle using half times side 1 times side 2 times sine the angle between the two sides? And how we find the area of the sector using the formula theta over 360 times pi r squared? And at last, how we use the formula of finding the volume of any 3D object, which is area of the base times the height or the vertical distance between the two identical opposite bases. Please watch it a couple of times. Try to solve it on your own from A to Z. Keep on solving it and rewinding this video until you are capable to solve it on your own without making any mistakes. Thank you so much for watching and sharing the link of this video, and for subscribing to my YouTube channel.